So I'm going to do this introduction for kinematics. So the symbol that we usually use, S will represent displacement. Okay, there's a lot of confusion with between displacement and distance traveled. So later on, I'll illustrate the difference. So for displacement, right, it is how far are you away from O? So it's like a GPS tracking your position away from O. So actually displacement doesn't give you the distance traveled. And V will stand for velocity. A, this one should be small letter. So A stands for acceleration. So the relationship will be, you are differentiating with respect to T. So you'll be given the formula will be with respect to T. So if you are going to differentiate, you're also going to differentiate with respect to T. Okay, so I think I should write it d dt. So you can also be asked to integrate back. So you are integrating with respect to T. So that will be the relationship, differentiation and the integration relationship for kinematics. So we run through a few basic terminology before we illustrate the difference between displacement and distance travel. So a lot of time, if let's say you have initial position, so initial means T equal to 0. So you will substitute T equal to 0 into the expression for displacement. Initial velocity, you substitute T equal to 0 into the expression for velocity. Initial acceleration, you substitute T equal to 0 into the expression for acceleration. So this one is pretty simple. The confusing one will be sometimes when they ask for maximum velocity, or they can ask for minimum velocity. So that is your minimum maximum in differentiation. So when you are doing something like minimum point, you differentiate equal to 0. So in this situation, you are going to differentiate velocity equal to 0. So if you like to find the minimum velocity or maximum velocity, your job is to differentiate velocity equal to 0. And in this situation, if you are differentiating velocity, you get acceleration. So if you look at the relationship, if you differentiate velocity, you are getting acceleration. So you end up setting acceleration equal to 0. So that's the implication of minimum or maximum velocity. And we also get maximum displacement. That means the furthest away you can get from O. How far, what is the furthest you can get away from O? So you will differentiate displacement equal to 0. And if you explore the relationship again, if you differentiate displacement, you are getting velocity equal to 0. So that's based on your logic of maximum area, maximum volume, okay, minimum, maximum point, all that. It's the same idea. So one of the more critical one will be instantaneous at rest. Instantaneous at rest represent the change in direction. So this one represent the idea of change in direction. So they can rephrase it as change in direction, or they reverse it in direction. So anyway, that is the idea of U-turn. So the mathematical representation will be velocity equal to 0. So they use this representation to signify a change in direction. Velocity is equal to 0. So if you would like to find which timing the particle is making a change in direction, reverse direction, you set velocity equal to 0. So that's one of the more commonly used expression. So next at O represent, this is also another common one. Next at O is actually representing the next time you return to the original position. That means when you return to the original position, you got no displacement because you're back to the original point. So most of the time is S equal to 0, provided 0 is your original position. So these are the few terminology that is commonly used. Okay, so let's illustrate the difference between displacement and distance traveled. So the idea about displacement and versus the distance traveled. Distance traveled is how much is being moved. Okay, so I will usually use something like this to illustrate. So can you imagine, for example, this is the original point, and this is point A. So think about point A. Okay, point A, maybe this one is 8 meters. So OA is 8 meters. So at point A, the displacement is 8 because you are 8 meters away from O. The distance traveled, it is also 8 because you are moving from O to A. Okay, so that is the basic thing first. So here I decided I'm going to make a reverse. I'm going to make a reverse. And I come to position B. So position B is something like this. This is 3 meters. So at B, the displacement is 3 meters. Because you're 3 meters away from O. So you're going to be very near to the original point already. But the distance traveled is not 3 meters. So if you explore the distance traveled, so just now you travel 8, then here you're traveling here, this part. So this part is 8 minus 3. So how far have you traveled? You have traveled the original 8, and you also traveled the 8 minus 3. So which is a 5, 8 plus 5 is 13 meters. So displacement is how far you are away from O. It doesn't equal to the distance traveled, only in some situation. So like at point A, the distance traveled and displacement is the same because it's a straight line. So once you change your direction, the displacement will be changed, the distance traveled will be changed. So this is the idea between the displacement versus the distance traveled. So that's why if you are going to find distance traveled, you should always be finding any change in direction. The change in direction will affect the distance traveled.